Once again, welcome to ChemSkills Podcast Suite. This is podcast number 5, and the topic of this podcast is writing ionic formulae. First of all, let's begin by looking at the question, what is an ionic formula? An ionic formula is a chemical formula that contains ions. What are ions? Ions are either positively or negatively charged atoms or groups of atoms. How can we tell if a formula is going to be ionic? Most of the time, ionic formulae are formulae of metals and nonmetals. Ionic compounds are metal, nonmetal compounds, 99.99% of the time. But how can we tell if an atom is metallic? Now, many of you would be familiar with lots of metallic elements, but there might be some of the odd, obscure, rare metallic elements that you've not heard of before. Well, if that's the case, then you need to refer to the periodic table and look at the position of these elements in the periodic table. This is a periodic table that I obtained from the website webelements.com. And I highly recommend that website for any information about the elements. In fact, most recently, element number 117 was reported on the website as having been discovered in April 2010. In any case, looking at this periodic table, we need to be able to identify where the metals are and where the non-metals are. Because if you're asked to write the formula for a compound with an unknown element, to establish whether it's ionic, you need to see whether it's either metallic or non-metallic. So let's draw in a line that separates the metals from the non-metals. Now, to begin the line, we start above aluminium and zigzag our way down the periodic table from aluminium down to unseptium, and extend the line onwards and downwards, and we get something that looks like this. Now, all of the elements enclosed here on the left of this red line are metals, and you can see that there is by far a greater number of metallic elements than those outside the red line, which are the nonmetals. So if an ionic compound or an ionic formula that you're asked to write contains an element from this section, the metal section, and an element from this section over here on the right, the non-metal section, then you're being asked to write an ionic formula. And if that's the case, then you need to follow this following procedure. So let's just see if you've understood. Here's a little quiz. Which of the following are ionic? NaCl. Many of you would know that sodium is a metal and chlorine is a non-metal. If not, you go back to the periodic table and we look for sodium. Sodium here is on the left-hand side of the periodic table. Chlorine here is on the right-hand side of the periodic table. Sodium chloride is a compound of a metal with a non-metal, so it's ionic. So yes, sodium chloride would be ionic. Carbon dioxide, CO2, we go back. C is in the non-metal section, O is in the non-metal section, so this is a non-metal compound, so it is not ionic. HCl, hydrogen chloride. Hydrogen is just outside the metallic section, chlorine is outside the metallic section, so they're both non-metal, so this is not ionic. MgOH, brackets 2, magnesium hydroxide. Magnesium is on the left of the periodic table. Here it is in group 2. Oxygen, hydrogen in the hydroxide are nonmetals. So this is a compound of a metal with some nonmetals, so it is ionic. And SN brackets HCO3 brackets 2. This is tin bicarbonate. SN here is in the metal section. Hydrogen, which we've seen before, carbon and oxygen all are nonmetals. So SN brackets HCO3 brackets 2 is a ionic compound because it's made of a metal and a non-metal. So we can conclude that yes, sodium is ionic, carbon dioxide is not, hydrogen chloride is not, magnesium hydroxide is, tin bicarbonate is as well. But if they're ionic and therefore contain ions, and that is positively and or negatively charged atoms or groups of atoms, where are the ions? Well, the ions are not shown in these formulae. There's no positive or negative charge shown here, or here, or here, simply because they've cancelled out. And the numbers of positives and negatives balance. And so they are not shown because the resultant charge on this compound is neutral. They've been cancelled out. But we mustn't forget that the ions are still there. It's just that they are not shown. Now, looking at sodium chloride as an example, the sodium ion is still present, but it's one positive. The chloride ion is still present, but it's one negative. Because there's one sodium and one chlorine in sodium chloride, the positive and the negative cancel out. So here are some examples of ions, starting with positives. We have sodium ions that are single positive, magnesium ions that are double positive, and I've shown the magnesium ion as being twice the size because the charge is double that of sodium. And then there are aluminium ions which are triple positive, so this is 3 times the size of the sodium ion. Negative ions include the chloride ion, which it has 1 negative charge, the oxide ion, which is double negative, so it's shown here as double the size of the chloride, and the nitride ion, which is triple negative, which is shown here as triple the size of the chloride ion. So when we're writing the formulae for ionic compounds, the fundamental rule is that the charges must cancel out and or balance to leave the formula neutral. So if we're asked to write the formula for something like magnesium oxide, the magnesium ion, which is double positive, is shown this size. The oxide ion, which is double negative, is shown this side. The size of the ions or the charges are identical, but of opposite sign, which means that when they're matched together, 1 to 1, they cancel each other out. 2 positives with 2 negatives cancel out. So the formula for magnesium oxide would only need to contain 1 magnesium with every 1 oxide. And we'd write that as 1 Mg with 1 O as such, MgO. If we're asked to write the formula for something like magnesium chloride, again the magnesium ion is double positive, but the chloride ion is single negative. They don't balance. The chloride ion is smaller, it has less charge, half the charge of the magnesium. So we would need 2 chloride ions to get the same amount of negative charge to balance out the positive charge on 1 magnesium ion, which means that when 1 magnesium ion is combined with 2 chloride ions, we have a balancing of charge. The resultant charge on this compound would be 0, 2 positives with 2 negatives. So the formula for magnesium chloride would be written like so, MgCl2, showing 2 separate chloride ions. Now in our final example, aluminium oxide. Aluminium is a triple positive ion. The oxide ion is a double negative ion. Again, there's a mismatch. They don't balance out. So in order to balance out, we would need 2 aluminiums to give us 6 positive charges and 3 oxide ions to give us 6 negative charges, so that when they're added together, they balance each other perfectly and give a resultant 0 charge for aluminium oxide. The formula, therefore, for aluminium oxide would contain 2 aluminiums and 3 oxygens. Just before I conclude, it is also important to note that when writing the formula for ionic compounds, convention has it that the metal ion is written first, followed by the non-metal ion. Now, I hope that you found this useful, and please listen into future podcasts where I will explain how to write the formulae for covalent or molecular compounds. Thank you for listening.